basic sine, cosine, and tangent equations. So as you notice on this first page here, we have some basic cosine, sine, and tangent equations. We're going to reference back to these. So instead of me just breaking it down to you right now, let's just go back and forth, okay? As long as my computer and Word doc works great, we won't have no problems with that. All right. So example 1 says find all real numbers that satisfy the equation of cosine x minus 3 equals -4. So in order to do that, we need to get cosine x by itself, and then we're going to find its inverse. So I'm going to do that by adding this -3 to both sides. Now I have cosine of x is equal to -4 plus 3, which is -1. Now I'm going to take the inverse of this, which gives me x equals cosine inverse of -1. So before I go any further, let's talk about these two steps here. Now, when I have it written as cosine x is equal to -1, then we know what a is because the cosine, or it could be sine or tangent, whatever it is we're working with, of that x or whatever value right here is equal to a. Let's look at a. In this case here, a is -1. So we're going to go up to the top and let's figure out what specific formula we need to use. And we're working with cosine, so let's look at the cosine section. It says here, if a falls between -1 and 1, and it's not equal to 0, we're going to use this particular one. If cosine of x, which means a is equal to 1, we're going to use this one. If a is 0, this one. If a is -1, this one. And this is the one we're wanting. Now it says if you take the absolute value of the a and it's greater than 1, then there's no solution. So we need to make sure that we understand these. So I encourage you to have this front page right here set to the side when you're working on the section as you're learning this material. It'll help you to get master these equations down. All right, so knowing that a is -1, so we know that we're going to be using the, and let me go back up there. My apologies, guys. And if you notice, it's in radians, and if we ever have to work in degrees, we could. So it is pi plus 2k pi, so let's put that in there. We know that x, we have a set of x that builds on pi plus 2k pi. Right? That's what it said up there. Well, let's solve for this. Cosine inverse of -1. Well, that gives me pi, which makes sense because cosine is this x value, and we know that this is 0 degrees, or in radian 0. It goes over here to pi, and then it goes over to 2 pi down here. And here, cosine is -1, and over here, cosine is 1. So that makes sense. So it is pi. That works out great. So I was looking at this notation up here. Let's just see. No, that's right. Which makes sense because cosine of -1 is pi. So it gave us the answer up there. Now, this is the formula you would use to find all real numbers. In this particular question, we just wanted the actual formula. K is our constant here. So when we're starting to find our real numbers, we'd plug in values like for K, we could say 0, we could say 1, we could say -1, 2, and -2. I always use the small, and I go back and forth to around the 0. It makes it a lot easier. And then you can find the values. But in this case here, all we want is the formula. So let's go to the next one. The next one says find all real numbers that satisfy the following equation. We have cosine of x minus the square root of 0. In order to do that, then I need to add the square root of 2 to both sides. So now I have cosine of x is equal to square root of 2, because 0 plus that is just it. And then let's find its inverse. Before we go any further, though, let's talk about what is the square root of 2. So if I plug in the square root of 2 in my calculator, I get, square root of 2, square root of 2. I get a decimal, and I'm just gonna write approximately, okay, for over here. So you can, A is square root of 2, and it's approximately 1.4142 and it goes on around right there. Anyways, the next digit was 1, and it didn't change the 2. So this is greater than 1. So we're gonna say no solution and move on. Example 3 says, okay, we have sine, or find all real numbers that satisfies this equation of sine x is equal to the square root of 3/2. So it did a lot of work for us. Now all we have to do is just find its inverse. But before I go any further, let's acknowledge what a is. A is the square root of 3/2. And if we was to type that in our calculator, square root 3/2, and that gives me 0.866025 and so on. So it's less than 1. So we are okay so far with that. Let's go up here right quick and let's just look for the formula we're going to use. Remember, we're talking about sine, so let's look at the sine one. So A does fall between -1 and 1. It's not equal to 0. So let's determine which one of these. Okay, because A is not 1, it's not 0, it's not -1, and it's not greater than 1. So it ruled out 2 through 5. We're on 1. Now on 1, we have 2 sets to pick from. Is A greater than 0 or is it less than 0? Well, A is positive, so it's greater than 0. So we are going to work with this right here. So let's go to that problem and let's write it down. Well, let's first write its inverse and then go to that next step. So the inverse of sine, when I plug it in, I get pi thirds. All right. So if you'll notice on the formula, the sets we're going to build on, they have x is equal to s plus 2k pi, or x is equal to pi minus s plus 2k pi. Well, they're using s, so that way we can differentiate between the x and s. Okay, so once I find the inverse here, my x here will become x equals s of sine inverse. So whatever I solve for here, it's going to give me my s value. Okay, oops, that's a 3. All right, so now we can plug it in. I got pi thirds plus 2k pi. So x equals that. And then over here, I got pi minus pi thirds plus 2k pi. And since we don't know what k is, this would be my first part, and it'd be done. And then my second part, I put these two together. So in order to do that, and notice I have a fraction involved, I need a common denominator, which is a 3. So now I got 3 pi minus pi over 3, which is 2 pi thirds. So now my next one is x is equal to 2 pi thirds plus 2k pi. Okay. Let's do our next one. It says find all real numbers that satisfy the equation of cosine x half. So we know what a is because they already did the first part of the work for us, right? So a is a half. So since we know it's a half, it's not 1, it's not 0, it's not -1, and it's not greater than 1. So we know that we're going to come up here and pick the one where a falls between -1 and 1. And we're going to use this one. Okay, and let's find out what our numbers are. Well, our formulas we're going to use. Later on, the further we get into this section, or in this particular chapter, we'll start finding them. All right, So, let's go ahead and write the inverse for cosine. Which is going to be pi thirds. I'm going to take that formula that it said that we're going to work on a set of x that builds where x is equal to s plus 2k pi, or x is equal to 2 pi plus or minus. It should be a minus. I'm going to put a minus here and see if my eraser will work today. Okay. Now let's go back to the pen. Okay. Minus s. There we go. Now, we know what s is, right? It's going to be that pi thirds. So let's plug it in. Because remember, x now can be replaced with s. Because we need to differentiate between the s and the x. Well, we don't know what k is, so we do know this much. Let's plug in here for s. Again, we don't know what k is, so we're going to leave the 2k pi alone. This part here, we can combine. Since it's a fraction, we need a common denominator, which is 3. So now I got 6 pi minus pi over 3, which is 5 pi thirds. So now I got x is equal to 5 pi thirds plus 2k pi. Okay. So example 5. Let's solve it. Let's do the same thing. Well, we notice what a is because they already have it set up for us that way. So again, we know that a is, and you can type it in your calculator just to make sure. But square root of 2 is less than 1. And then we're going to take half of that. We're going to know that we're still going to have less than 1. Okay. So a is not greater than 1. It's not equal to 1. It's not negative 1, and it's not 0. So we're going to go back to is a. Now solve for s, and is s greater than 0 or is s less than 0? Because those are the formulas we're going to pick from. So hopefully you have that form down beside you instead of rolling back and forth on the screen. So let's solve for it. That means we got to find its inverse. I know x is going to equal s cosine inverse of that square root of 2 halves. Well, I know square root of 2 halves is pi fourths, right? And it's a positive value. Since it's a positive value, we know that s is greater than 0. So let's use the formula that was given to us. The set builds on x equals s plus 2k pi, or x equals 2 pi minus s plus 2k pi. All right, now let's plug in for s. And this side works out. Look at that. Now let's plug in over here. And combine the part that we can combine, which is these two. And it's a fraction, so we know we need to find the common denominator. Now we get 8 pi minus pi over 4, which gives me 7 pi fourths. So now I have x equals 7 pi fourths plus 2k pi. There we go. Okay, let's do our next one. Example 6 says find all real numbers that satisfy the following equation. We have tangent x plus the square root of 3 thirds. Okay, so This one here, we need to do some work because we don't know what A is. However, since we are working with tangent, let's go back up to the top right quick and let's look at its formulas, which it has a different set of rules. It just says that A is any real numbers. So what we're going to have to do is figure out what is S. If it's greater than or equal to 0, we'll use this one. If it's less than 0, then we'll use this one. So let's go figure out what S is. A is not a factor here. So let me erase this right here. Give the computer time to catch up. There we go. Now let's subtract the square root of 3/3 to both sides. And let's take the inverse of tangent, which we know x is going to be now S. So we're going to take the tangent inverse, plug in the negative square root of 3/3 in your calculator, you get a negative pi6. So this tells me that S is less than 0. So we're going to use the formula that represents that. So we have a set of x that builds on when x is equal to S plus pi plus k pi. Now cosine and sine, we're talking about 2 pi, which makes sense because sine represents the y value and the cosine represents the y or the x value. And they do have this function which it could go from pi to 2 pi. It could go from pi halves to pi, whichever. You kind of get the point. But tangent, it has a function like this, right? And that's a very bad representation. Its inverse is something like, or its inverse would be something like that. It won't be all wavy. So that means that we are only working with pi as its, you can say, range, okay? Now that we know what S is, I'm going to plug it in. We don't know what K is because we're not plugging in those values. We're just looking for the formula. I do know in order to add or subtract a fraction, I need to find the common denominator, and it's 6. So now I got negative pi plus 6 pi over 6, which gives me 5 pi 6. Now my answer is x is equal to 5 pi 6 plus k pi. Now, if it does ask you for the other value, which it should not, but if it does, it does happen, then we would put in the, we would acknowledge S is negative pi 6. Just read what the instructions ask for. Example 7 says find all angles in degrees. So we're working in degrees now. That satisfies the following equation. Cosine alpha equals -1. So when I look at that, my A is equal to -1. And since I know that it equals -1, I'm going to go ahead and scroll up here and notice that cosine at -1 is this formula right here we're going to use. Well, they gave us everything we needed to know as far as that went. However, we're working in degrees, so we're going to have a little bit of notation difference. And it's also asking us to find the angles that satisfy it. So we're not going to plug in K, but let's talk about it right quick. So X is equal to, it was pi plus 2k pi, I believe. But we know that pi is equal to 180 degrees because we're on the unit circle. If it's pi, it's in radians. If it's 100, or if it's in degrees, it's 180. 2 pi is 360 degrees. So let's do that. I know that I have 180 degrees plus 360 degrees. Okay, so that's one answer. That is the answer from up above, knowing that A is -1. Now, it did say, let's find, and this would be our answer, okay? But if it wanted you to show it mathematically, we can say, oh, well, 360 degrees minus the angle. Well, that's 180 degrees. So check. So it's just another way of just looking at it. But this is actually just using the formula that was given, putting it in degrees. Don't make it harder than it needs to be. Okay, example 8 says, find all angles that satisfy the following. So we're going to have some work here to do, right? Because we got to figure out what formulas we want to use. So I'm going to go ahead and add this square root of 3 to both sides since it's a negative. Now I got 2 sine of alpha is equal to square root of 3. I'm going to divide by 2 because I need a coefficient of 1 on sine. And now I have this. Okay, so I know what A is. Okay, A is going to be square root of 3 halves. So let's look at that. Square root of 3 halves. If I was to plug it in my calculator, it's going to say that it is, and I'm going to just round, okay, because I'm going to drop off some digits. It's approximately 0.866. 0. Okay, so knowing this, we know it's not equal to 1. We know it's not equal to -1. It's not equal to 0, and it's not greater than 1. So it's going to go back to the fact, is S greater than 0 or is S less than 0? Then that determines which formula we're going to use there. So let's figure it out. So let's take the inverse of this sine. And when I do that, I get pi thirds, but we are talking about degrees, so it's 60 degrees. So S is actually greater than 0. So we're going to use the formula where the set of X builds on. X equals S plus K 360 degrees instead of 2 pi because we're working in degrees. Or X is equal to 180 degrees because remember it was pi minus that S plus that K 360 degrees. Now let's just plug in for S. That's 1. So that worked out. And let's plug in for S over here. And we're going to subtract the 180 degrees minus that 60, which gives me 120 degrees. And now we got X is equal to 120 degrees plus that K 360. All right, moving on. Okay, find all angles in the intervals of 0 degrees to 360 degrees that satisfy the equation. All right, so we're going to work at this just a little bit different. It's just wanting us to find the angles that are satisfying between these angles. Okay, so if you notice, we're in degrees mode, so make sure your calculator is still in degrees mode. Let's find the inverse here. Let's type it in our calculator. Let's round to the nearest tenths. And when I type it in my calculator, I get cosine inverse 1 or 0.1633. Make sure again we're in the right mode. And let's double check. We are talking about degrees. Cosine inverse. Okay, round to the nearest tenth, I get 80.6 degrees. All right, Now, that's going to be my first value, right? Within the 0 to 360 degrees. So you may be asked to list more than one. I would want to see both. I would want to see both values, okay? The next one is going to be the 360 degrees minus this 80 degrees, 80.6 degrees. And when I do that, I get 279.4 degrees. So this is my other value. So these two falls within that interval that satisfies this equation that was given to us. All right, so now let's do our next one. 10 says find all real numbers in the interval of 0 to 2 pi. So we're in radians now that satisfy the equation. So let's get the inverse of tangent. Let's get it all set up right. So we're going to have to add this one to both sides because it's negative. Let's divide by the square root of 3. And now let's take the inverse of this tangent. I'm not going to be too focused on the square root of 3 right now in the denominator because that's not my final answer. So, but we can still plug it in our calculator because it is a specific point. So I got to make sure and change my mode to radians. And now I'm going to take the inverse of tangent, that fraction 3 divided by the square root of 3. And it gives me pi thirds. Now, you can put it in decimal form if it asks us for it. Make sure I'm round to the placement it says. In this case, it would be 0 or the hundreds, 0.5. I'd round to it. And usually it asks us for 2 decimal places. But anyways, so these are the got the approximation exact. So just be sure and read what it asks us for. I want to use this one here. I'm going to use the exact. Okay, so doing that, I know that I have 0, 0 on top to 2 pi. So from 0 to pi. So I know from 0 to pi, I have, let me start off this way. I know my very first one is pi thirds. I know that. That's my very first specific point. Now let's figure out if I take pi minus that pi thirds, I'm going to find my next point within that, right? So if I take my pi, subtract that pi thirds, then I'm going to get 2 pi thirds. And again, if it wants it in decimal form, I would round to the nearest hundredths. Whoops, it's not a 0, it's a 2 point. Sorry about that, guys. 0.9. So again, just read, but I'm going to stick with the exact value. So 2 pi thirds. So now I got a second point, and now I want to find out from pi to 2 pi. So I'm going to say 2 pi minus that 2 pi thirds. So we got 2 pi minus the 2 pi thirds gives me 4 pi thirds. Okay, so that would be all my values. So if they would want you to list them, that would be 3 here. I would want you to list it. Now just read the homework assignment. Maybe it might only wants 2. Okay, let's do example 11. So example 11 says solve the following equation for this function that falls within this range here of negative 360 degrees to positive 360 degrees. So in order to do that, I need to get cosine of beta by itself. So I'm going to add the negative 5 to both sides. Then I'm going to divide by the 5. Now I got cosine of beta is equal to 5 over 5 is 1. Take the inverse. So now I got cosine inverse of 1. Cosine of inverse of 1 is 0. If you type it in your calculator, let's type it in there right quick and check it out. It's 0. So we know that based upon that information, we would go to our functions that were given to us when we were given 1 is equal to, we would say there is, remember when it said A is 1, then that means that, or the absolute value of A means there's no solution. So here we have cosine of beta is equal to 1. So based upon that information, there's no solution, right? Because of the rule. We also know that when cosine is at 1, it gives me 0. So your answer would be 0, and you could say no solution. Okay, let's do our next example. There we go. It says solve the equation. So we're giving an equation with a lot of work going on here. What I notice is I have a sign on this side of the equal sign and a sign on this side. I have a constant here and a constant here. So what I want to do is get the constants on one side and the signs all on the other. So I'm going to subtract the 6 sine of beta from this side because it's positive. So that means I'm going to subtract it from both sides. And the reason why I'm moving the signs to this other side is because I like to work left to right. So now I got 4 minus 6, which is 2 sine, or negative 2 sine beta, plus that 8 square root of 2. And now I need to move the 8 square root of 2 to the other side. Since it's positive, I'm going to subtract it. So now I have negative 2 sine beta is equal to 9 minus 8, which is 1 square root of 2. I'm going to divide by this negative 2. So now I have sine of beta is equal to, because negative divides positive is negative, square root of 2 halves. And then I'm going to find its inverse. Okay, so now I know what A is, right? If this would apply to this specific point here. Okay, what is my S in this particular one? It would be a negative 45 degrees because we are working in degrees. Remember, they gave us our range. So now that I know this, I know that if I was to go pick the formulas for this, I know that I'm going to have you can say X is equal to, oh, actually this here just wants the degrees. I was going to plug it in the formula, but let's do this. So we have a negative 45 degrees. It did say 0 degrees at 360. My apologies. I should have drawn this out where I could see what I was working with. So if I'm going to do that, then I'm going to go to 180 degrees. So we're going to do just like we did the one above, right? So this is my first one, negative 45 degrees. Let's figure out from that point to 180 degrees. So 180 degrees minus that negative 45 degrees. Well, we got negative times negative becomes positive. So now I got 225 degrees would be my next point. And then from that, I need to figure out the 360 degrees minus the 45 because we can't go over the 360, right? That's not what it asks for. It said stay within 0 to 360. So when I subtract it, my next point would be 315. So those are all mine points.